Okay. All right. Our next topic is on arc length. If you have a circle right here, and let's say you have a central angle of 30 degrees, right there is a 30-degree angle. It's called a central angle. See, it's at the middle here, it's a central angle, as opposed to what we won't be using for this class is an angle like that of 30 degrees. This is called an inscribed angle. We won't be using that, okay? So central angle. You see the difference? Okay. So we're talking about a central angle of 30 degrees, and what they'll ask you on the problem is the following. They'll say, what is the length of the arc of the circle? In other words, what is this length right here? Now notice it's not a straight line, it's curved. You follow? This is a curved line. They want to know what is the distance from here to here. And they call this S, the arc length. So that's this distance here that's been cut by a central angle. You see it? This central angle of 30 degrees has cut this arc on the circle. And this arc, S, is what we want to find, the length of this arc. And it's a curved line, it's not a straight line. Okay? So what they have to tell you is the radius. And and I'm going to make up a problem here, and then we'll do our example problem. So let's say they tell us that we have a radius of 10 inches. Okay? That means the distance from the center of the circle to the outside of the circle, this line right here, is 10 inches long. When we find the arc length of the circle here, the answer will have the same units as the radius. And the radius is in what units?
Inches.
Yeah. So our answer is going to be in
Inches.
Very good. All right. So the answer will always have the same units as the radius was given to you. And the radius was given, the distance from the center of the circle to the outside of the circle was given to us as 10 inches. Now, the arc length S, this arc that's been cut by a central angle of 30 degrees, is given to us by this formula right here. S, arc length, is equal to the radius, lowercase r, times the angle of that was given, the central angle, but, and here's the big but. Big but. Okay, the big but is the angle, when we use it, has to be given to us in radians. So this is actually a conversion problem in hiding, is what it really is. They're always going to give you the central angle in degrees, and before you can plug into the formula, this is the formula we're going to use, and I'll tell you how to use it in just a second. But before we can plug into this formula, we have to first convert our angle from degrees to
Radians.
yeah. So let's first, before we can do this problem, let's convert 30 degrees to radians. How do we do that? Well, it's a three-step process. Okay, 30 degrees is equal to some number of radians. We start out by step one. We say that here's our key. Pi radians is equal to how many degrees?
180 degrees.
Very good. And step two is to make two fractions out of step one. You say this over this, so pi radians over 180 degrees, or this over that, 180 degrees over pi radians. And now the step three is where we do our actual converting. We're going to take what we're converting, which in this case is 30 degrees, and we're going to multiply it times one of the two fractions from step two. I'm going to move it down here so I have a little more room to operate. I apologize. So we have 30 degrees to step three, and we're going to multiply times one of the two fractions from step two, and we're going to end up in the units of radians, because we have to have our angle in radians before we can plug into this formula. Good? All right. So which of the two fractions should I use as my multiplier, left or right?
Left.
Yes. Good job, Marco. We always pick the fraction that has the same units that we're converting out of. since we're converting out of degrees, we are going to pick the fraction that has degrees in the denominator. Why? So we can do what? Cancel our units. So the degrees will cancel between the numerator and denominator, just like numbers can cancel. Now we're going to multiply, and since this is a fraction, we take a second to convert this into a fraction by putting it over 1. And now we multiply straight across the top. 30 times pi radians over 1 times 180. Now we need to reduce this. I am going to rewrite 180 so that is this number times another number. So I want to rewrite 180 so that it is 30 times what number?
6.
Good job. And now I can now cancel what number between the numerator and denominator?
30.
Good. So that reveals my answer. 30 degrees is equivalent to what?
Pi over 6 radians.
Good job, pi over 6 radians. Yeah, we don't say pi radians over 6, but good job. Pi over 6 radians, nicely done. So then, we're not done yet. He did good, but we're not done with the problem yet. We now have to plug our central angle, which is 30 degrees, but we convert it to radians. Pi over 6, we have to plug that in here. So to finish the problem, we have S, arc length, is equal to our radius, which was given to us as what?
10 inches.
Yes, 10 inches, and we have to multiply it times our angle, which is pi over 6, okay, radians. Now, and our answer will always be in the same units as our radius. Our answer is going to be in what units?
Inches.
Inches, very good. Now, when I multiply a fraction times anything, I want both things to be a fraction. So I'm going to take a second to turn this into a fraction by putting over 1. Now I can multiply straight across the top. I get 10 pi over 1 times 6, 6. Now, this is in inches. Now, this is one of the only places where we're actually going to convert pi to a number. Most of the time, when we get pi in our answer, we leave it as pi, okay? So this is the only one place where you're actually going to go to your calculator and you're going to multiply it out right here. We have to, I'm sorry, right here. Where's our answer?
Our answer's to the left. Inside the circle.
Here. Okay, so what we have to do to finish the problem is we actually have to multiply 10 times pi, get a number, and then divide it by 6. So on your calculator, Marco, multiply the numerator 10 times pi. So find pi on your calculator, which is approximately 3.14, but I want you to use your calculator value of it. I think you have to hit shift, and then do you see it? Is that it? Times 10 equals, and then divided by 6 equals. So 10 times pi is approximately 31.4, and then divided by the denominator. So what are we getting for our answer approximately? You have to divide it by 6.
It's not giving me anything.
Oh, you have to hit, I'm sorry, the S to D button. Not the orange button, the S to D above it. You see it? All right, good man. He's got the Casio, and it gives him the answer in pi, and now he has to hit the S to D button to convert it to a decimal number. Okay? So 10 times pi equals, divided by 6 equals.
5.23
Good job. And what are our units?
inches.
5.23 inches. All right? That is the length, good job, of the arc that is cut by a central angle of 30 degrees with a radius of 10 inches. This length of the arc that was cut is 5.23 inches approximately. Okay? All right. Good?